Hello students, welcome back to my channel once again. So this video I am going to explain applications of Kohlrausch law of independent migration of ions. In the previous video I discussed the Kohlrausch law of independent migration of ions. This is the continuation students. When you are asked the question Kohlrausch law, you have to include applications also. Okay, so let's learn the applications. The first application of Kohlrausch law to determine the equivalent conductance of weak electrolytes at infinite dilution. So how to determine? How is it possible? Yes, it is possible. The equivalent conductance of weak electrolytes at infinite dilution can be determined or can be obtained or can be calculated from the known values of equivalent conductance of strong electrolytes. So I will show you an example students so that it will be easy for you. The first example that I have taken here is acetic acid CH3COOH. It is a weak acid. Lambda infinity of CH3COOH. What is lambda infinity of CH3COOH? Equivalent conductance of acetic acid at infinite dilution. Okay, so this can be calculated from the known lambda infinity values of strong electrolytes. So what are the strong electrolytes that are taken here? CH3COONA, HCl and NaCl. From these strong electrolytes, the lambda infinity of acetic acid can be determined. Sodium acetate, HCl and NaCl. How to determine students? So below you can see lambda naught CH3COONA plus lambda naught HCl minus lambda naught NaCl. What is lambda naught CH3COONA? Equivalent conductance of sodium acetate at infinite dilution plus equivalent conductance of HCl at infinite dilution minus equivalent conductance of NaCl at infinite dilution is equal to, okay, now lambda naught of CH3COO minus plus lambda naught of Na plus. Okay, this is dissociated into acetate and Na plus. Next, plus lambda naught HCl is written as plus lambda naught H plus lambda naught Cl minus. Next, minus lambda naught NaCl minus lambda naught Na plus minus lambda naught Cl minus. Okay, so this Na plus will be cancelled. This Cl minus will be cancelled, and what remains? Lambda naught CH3CO minus and lambda naught H plus. Okay students, that is the formula that we use here to determine equivalent conductance of weak electrolytes at infinite dilution. Okay, understood students? This is very easy, not big mathematics is here. Okay, so therefore concluding, lambda naught of CH3COONA plus lambda naught HCl minus lambda naught NaCl will be equal to lambda naught CH3COOH. Okay students, this is the way we calculate the equivalent conductance of weak electrolytes at infinite dilution from the known values of equivalent conductance of strong electrolytes at infinite dilution. Next, one more example I have given. Lambda infinity of NH4OH. This is a weak base. Okay, it can be obtained from known lambda infinity values of strong electrolytes, ammonium chloride, NaOH and NaCl. So how to calculate students? Lambda naught NH4Cl plus lambda naught NaOH minus lambda naught NaCl is equal to, okay, so without seeing this, will you be able to write students? Try to write down. So dissociates, NH4Cl gets dissociated into NH4 plus and Cl minus. Okay, so lambda naught NH4 plus lambda naught Cl minus plus lambda naught Na plus lambda naught OH minus lambda naught Na plus. Here it should be minus not plus. So lambda naught Cl minus. So after writing this, what remains, students? Lambda naught NH4 plus lambda naught OH minus. Okay. So this plus lambda naught Cl minus and minus lambda naught Cl minus gets cancelled. Plus lambda naught Na plus and minus lambda naught Na plus gets cancelled. So this and this remains. Okay. So therefore, below concluding, lambda naught NH4Cl plus lambda naught NaOH minus lambda naught NaCl is equal to lambda naught NH4OH. So this is a weak base. The equivalent conductance of weak base, that is NH4OH or ammonium hydroxide at infinite dilution, can be calculated from the equivalent conductivity values of strong electrolytes at infinite dilution. And the strong electrolytes here taken are NH4Cl, NaOH and NaCl. Okay students, this is the first application of Kohlrausch law of independent migration of ions. Second application, students, put the side heading, to determine solubility of sparingly soluble salts. Okay. So do you know the meaning of sparingly soluble salts, students? Yes, they are not completely soluble. So for example here, silver chloride, PbSO4, BaSO4, etc. such salts are insoluble in water. Okay, they are not completely soluble in water, they are insoluble in water. So because of their extreme low solubility, aqueous solutions of such salts are considered to be solutions at infinite dilution. Okay, they are not completely dissolving in water, students. So add some water to these salts like silver chloride, lead sulfate, barium sulfate. Such aqueous solutions are considered as solutions at infinite dilution. Okay, so they are sparingly soluble salts. Now, their solubility cannot be determined by normal or ordinary methods, but it can be calculated using Kohlrausch law and conductance. Okay, so the solubility of sparingly soluble salts can be determined, okay, from Kohlrausch law and conductance. These two can help us to know the solubility of sparingly. So that means to what extent these salts are soluble in water, that can be determined from Kohlrausch law and conductance. That is why this to determine solubility of sparingly soluble salts is one of the applications of Kohlrausch law, students. Okay. So let us take an example. First one is silver chloride. Example here for AgCl. So AgCl lambda infinity, okay, one of the steps to determine lambda infinity of AgCl, students, is equal to, what is this, students, do you remember? Yes, this is Greek letter kappa. So what is denoted by kappa? Specific conductance is denoted by using kappa. So K into kappa into V. What is V here? V is volume in cc containing 1 gram equivalent of the salt. Okay. So lambda infinity of AgCl can be determined from these two values. Okay. So kappa into V. Now from this expression, V will be equal to lambda infinity by kappa. Okay. So this V will be equal to lambda infinity by kappa. Okay. Now, one more. Lambda infinity of AgCl can be calculated from Kohlrausch law as follows. Okay. That's why I told you to watch Kohlrausch law of independent migration of ions before learning the applications of Kohlrausch law, students. Okay. So this is discussed in the previous video. Lambda infinity of AgCl can be calculated from Kohlrausch law as follows. How? Here it is. lambda naught of AgCl is equal to lambda naught Ag plus lambda naught Cl minus. From Kohlrausch law, lambda naught of AgCl can be determined like this, students. Okay. So, equivalent conductance of an electrolyte at infinite dilution will be equal to sum of equivalent conductivities of cation and anion. Okay. Both the ions. Okay. Now, solubility of AgCl can be calculated as follows. Okay. So, two steps we have seen. From those two steps, how to calculate solubility of AgCl. Look here, students. Vml of solution contains 1 gram equivalent of AgCl, that is 143.5 grams. Then 1000 ml of solution contains dash gram equivalents of AgCl. If Vml of solution contains 1 gram equivalent of AgCl, 1000 ml contains how many gram equivalents of AgCl? So, it is equal to 1000 into 143.5 divided by V. Okay. So, equivalent weight of the salt into 1000 by V. Equivalent weight of the salt is how much? 143.5 into 1000 by V. Okay. So, it is equal to 1000 into 143.5 by V. Okay. So, it becomes into kappa by lambda infinity. Why? Because V equals to lambda infinity by kappa. We have seen now? Okay. So, this becomes this. Why? Because V is equal to lambda infinity by kappa. Kappa goes to the numerator. Therefore, finally, put it in a box. What are we learning? Solubility of AgCl. So, this is lambda infinity of AgCl. So, lambda infinity of AgCl means what? Is equal to lambda infinity of Ag plus lambda infinity of Cl minus. So, the final expression goes like this. Therefore, solubility of AgCl is equal to 1000 into 143.5 into kappa by lambda infinity of AgCl is equal to nothing but lambda infinity of Ag plus lambda infinity of Cl minus. Okay, students. So, this is the way we can calculate or we can determine solubility of sparingly soluble salts using Kohlrausch law. Got it? So, based on this, we have problems also, students. I will show you one or two problems so that it will be easy for you to understand. Are you all ready, students? So, how many of you are interested in doing numericals? Just raise your hand in the comment section, students. Okay. Problem number 1. Calculate lambda infinity of NH4OH. Okay. That means equivalent conductance of NH4OH at infinite dilution. Given lambda infinity values of NH4Cl, NaOH and NaCl. So, the value equivalent conductivity values of NH4Cl, NaOH, NaCl at infinite dilution are given as 129.8, 248.1 and 126.4 ohm inverse centimeter square equivalent inverse respectively. These are the units of equivalent conductance, students. Okay. Now, write down the formula. Lambda naught of NH4Cl plus lambda naught NaOH minus lambda naught NaCl is a direct substitution, students. Okay. So, 129.8 plus 248.1 minus 126.4 which is equal to 251.5 ohm inverse centimeter square equivalent inverse. Therefore, lambda infinity of NH4OH is equal to 251.5 ohm inverse centimeter square equivalent inverse. When such numericals are there in the question paper, don't leave this problem, students. Okay. So, direct substitution, write down the formula, direct substitution, you will get full on full. Next, second problem. The specific conductance of a saturated solution of AgCl is 1.24 into 10 power minus 6 ohm inverse centimeter inverse. Here specific conductance of AgCl is given this much, students. The ionic conductance values of Ag plus and Cl minus are 53.8 and 65.3. ohm inverse, centimeter square, equivalent inverse at infinite dilution respectively. Now calculate solubility product of AgCl. This is the second application of Kohlrausch law of independent migration of ions. Just now we have seen. Based on that we will do this, try to do this numerical, students. So write down solubility is equal to 1000 into 143.5 into this value is provided in the numerical 1.24 into 10 power minus 6 by 53.8 plus 65.3. Okay, below 1000 into 143.5 into 1.24 into 10 power minus 3. This 10 power minus 6 I am splitting, students. 10 power minus 3 niche. If you add these two, we will get 119.1 into 1000. Where from this 1000, students? This 10 power minus 6 I have written 10 power minus 3 here. In the denominator I have taken 10 power 3. Okay, when this minus comes to the denominator it becomes plus. So 10 power 3 means what? 1000. This 1000 and this 1000 gets cancelled. So what remains? 143.5 into 1.24 becomes 177.94 by 119.1 into 10 power minus 3. If you divide these two, this with this, you will get 1.494 into 10 power minus 3 moles per liter. Just a substitution here, students, in the solubility formula of AgCl. This is the second application of Kohlrausch law of independent migration of ions. Okay, students, this is all about applications of Kohlrausch law. Okay, so the previous video and this video combine and write down in your notebook, students. Okay, so problems you need not include in the numerical. If you are asked numerical in the question paper in the exam, then only you do the numerical. Okay, or else simply write down Kohlrausch law and its applications in the exam. If you are asked numerical, then try to attempt or do the problem also, students. Okay, so this is all for today's video, students. You please kindly try to learn, because this is one of the important questions of electrochemistry. Those who are watching for the first time, please don't forget to subscribe, students, like and share with your friends. Meet you in the next video with a new topic, students. Take care. Bye-bye.